Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology turned podcast. Everyone, welcome into the program. I hope that you're doing well today and you are ready for today's program because we have the one, the only, Mr. Ralph Bond. He'll be joining us here in just a moment. He is, of course, our science and tech trends correspondent, and he has a 4 stories as is tradition. And yeah, you know, all of them are really great. The first one, I'm glad that he dedicated so much to it because the first story has such a large implication, I think, for, obviously for our day-to-day lives. But, ladies and gentlemen, going into the weekend, I know that there are places in the southern U.S. that are dealing with like their 30th straight day or something like that of 110 degree weather. Absolutely insane. And the way that I understand, climate change, I know I'm preaching to the choir here, but the abnormal is going to start getting more normal year over year. So, it's not going to be like, in 50 years a switch will flip and suddenly we can't live on Earth anymore. It's going to slowly, kind of raise the heat. So I'm sure people down there in Texas and California and, the southern states are really looking forward to substantive, wow, that's a hard word, good changes towards a better climate and a better economy. And again, it's a win-win because everything from story number 1 all the way through have very cool and fun implications. And cool and fun is exactly how I would describe our segments with Ralph. So before we get started, computeramerica.com, that's where you'll find everything, past shows, future shows, show notes, articles. Show notes are a big one, of course. We'll have those posted by the time that you hear this. And with that being said, ladies and gentlemen, let's go ahead and jump right into it with Ralph. So, as I said before, science and tech trends correspondent, and of course, longtime Computer America contributor, Ralph. Welcome back onto the program. How you doing?
It's great to be back, Ben, and happy Friday, everybody. And when I say happy Friday, it's because Ben and I, every Friday, give you technology and science advancement stories that will, we hope, leave you feeling happy instead of sad, which is what most of the news cycles out there do. They're so negative, wars and problems and disharmony in our government. No, leave that all behind. We're going to talk about everything from robotics, medical technology, sustainable energy technology, transportation advances, space research, physics, you name it. And we've got 4 stories to share with you. And again, Ben mentioned in passing the show notes. Come out to computeramerica.com. Get the show notes. That's where I put the links, the attributions, who wrote these stories, where they come from, sometimes supplemental information, images. All of it's there for you to dive deeper because we're just going to give you a condensed highlights of these 4 stories. So with that said, we can dive into the first story if you're ready.
I am absolutely ready, and I was really having fun, kind of reading this on my own. But it seems to be the past couple of weeks we have some kind of new battery technology. I think for the past couple of weeks we talked about was it silicon ion or something like that. Either way, lithium ion is what we know and traditionally use, but there is a lot of research past lithium ion, and today is no different. So, story number 1.
Yeah, and folks, talk about being a trends correspondent for the show. This one is really a very hot trend that's part happening right now and part promise for the future. So it's kind of a fun mix. Here's the headline: Toyota touts solid state EVs, electric vehicles, with a 932-mile range and a 10-minute charging time. They hope to achieve this by 2027. Again, what a trend. And you're going to find out Toyota is not alone at all. In fact, there's some solid state battery EVs out there right now. And we'll get into that. Again, the show notes have the link. I even have a supplemental link to dive deeper into the technology if you want to do that. But here we go with the story. So Toyota says it has found a technological breakthrough that will allow it to bring solid-state batteries to market for its cars as early as 2027, so a few years off. It's one of several advanced battery technologies that will underscore Toyota's new EV focus, all EV focus, by the way, as it pivots away from its former CEO's hybrid-centric strategy. And this comes right home to me because we have a RAV4 Prime, which is a plug-in hybrid, kind of a combination of both technologies. So solid-state batteries promise greater energy density, higher electric range, and faster charging that puts refueling time on par with a gas-powered vehicle. Now, let's be clear about that. On par, you're going to find out, we're talking about 10 minutes to fully recharge a battery, which compared to the 12 hours it takes mine to do it on my non-super power charger in the garage. Anyway, but to give you perspective. And here's the deal, folks. Researchers, scientists, and automakers have spent decades trying to crack the code on the commercialization of solid-state batteries. It's been a big challenge, but so far, now, this article's timeout, which came from, did I give the attribution? This came from PC Magazine, by the way, the article. And when it was written mid last month, this statement was relatively basically true. The author said no EVs have them as of this date. Well, now, in just a few weeks, all has changed. The article was published last month, and here are some updates. So I went out and I used the Bing AI chat search capability, and it came back when I said, what EVs or what electric vehicles out there now have solid state batteries? And here's the answer that came back. It says, according to my web search, there is currently only one commercially available electric car with a solid state battery. It is the Dongfeng, that's Dongfeng E70 electric sedan, which is only available in China and has been launched as a fleet of 50 taxis. And a little picture of it. It's a very nondescript, sort of normal looking little sedan car, but it has the solid state battery. And by the way, we're going to explain a little bit more about what the heck a solid state battery is as compared to a lithium ion battery. Okay. So here's my add-on. I went back and I asked the AI again about all solid state battery cars. And this week on 12th of July, Chinese electric vehicle automaker NIO has made a groundbreaking achievement in the EV industry by adding a 150 kilowatt hour solid state battery pack to its cars. And there's a little picture of it. It's an attractive little SUV type of car.
Right.
So this is now happening. And more to come. And the benefits we're going to get into are just stunning. But time out. Let's do a little explanation of what a solid state battery is, or what they are. A solid state battery uses solid electrodes and a solid electrolyte instead of the liquid or polymer gel electrodes found in lithium ion or lithium polymer batteries. Now, in the show notes, if you want to dive deeper into this, I've got a little more explanation of solid electrodes and solid electrolytes. You can dive in and get more geeky if you want to, and I've got links to where the information came from. We won't do that right now, but again, they differ by using liquid or polymer gel electrodes found in lithium ion or lithium polymer batteries. So the solid boy, if I could say it, that would be good. Solid electrodes and solid electrolytes. That's the key. And then we're going to get into the benefits here for why this is so great. Oh yeah. Here's a fun thing in the show notes. I love this. That was in the article in PC Magazine. While solid electrolytes were first discovered in the 19th century, what? Several drawbacks have prevented widespread application. Developments in the late 20th and early 21st century have caused renewed interest in solid-state battery technologies, especially in the context of electric vehicles starting in the 2010s. So isn't that something? 19th century.
Yeah, when it comes to vehicle technology, and especially like this kind of technology, I mean, some of the first cars were electric cars. We
That's
just
true.
Yes. Circled back around to gasoline, and now we're coming back to electric. The principles are pretty well known. It's just getting it to work on scale that we need for cars. That's the part that they're finally tackling, and it's so good to see.
Well, yeah, and Ben, to your point about, and that is so true. If you look at the history of automobiles and electric vehicles, what is it, like in the 1890s or something? I think they had some electric vehicles or crazy stuff, turn of the century and so on. And again, the problems that have to date kind of plagued electric vehicles, charging time, in the case of the 100 years ago or so, it was the batteries were just so limited and so forth. But at least they were playing around with that idea.
Yeah.
But here's the deal. Really, the trend, the breakthrough, the significance of all of these solid state batteries for cars is charging time and range. Okay. So solid state technology batteries can provide potential solutions for many problems of liquid ion batteries, or liquid lithium ion batteries, rather, such as flammability. We've all heard about that. Limited voltage, unstable solid electrolyte interface formation. That's very geeky. Poor cycling performance and strength of the batteries. I'm not quite sure what they mean by strength of the batteries, but nonetheless, that's sort of the shopping list of problems that lithium ion batteries you have in your car today present. And then another thing that I thought was interesting in the article, they said materials proposed for use as solid electrodes in solid state batteries include ceramics, oxides, sulfides, phosphates, and solid polymers. None of these are exotic or weird ingredients. Okay. That's another aspect of this. And another side note I thought was interesting. Non-automobile or car related uses of solid state batteries to date include pacemakers and radio frequency identification devices and a variety of wearable portable devices. But they do a little deeper in the dive. You'll find out right now that very expensive technology for that application, but it does exist. And then finally, with regard to Toyota, Toyota says it's found a new material that gets around one of the core issues with solid state batteries, their longevity. Because even my RAV4 Prime, which is a plug-in hybrid, someday down the road, the batteries are going to have to be replaced. But Ben, here's what I'm hoping, and I hope this is true for all the Tesla owners and everybody else, that when that day comes, you got to swap out the battery, that it can be swapped out with a solid state battery.
Yeah.
Bing! Wouldn't that be great? And then, as you can imagine, not only for Toyota, but for the Chinese and for everybody else that's really starting to get into this, the next challenge will be mass production. Toyota says its breakthrough batteries will hit the market in 2027 or 2028. Consider the fact that the Chinese already have this, and they're putting it on the road now. So salute to the Chinese on that regard, I guess. So this will give Toyota's EVs at that time period, around 2027, 2028, they claim at that time, those cars will have a 745-mile range. What? And significantly greater than any gas-powered car today, of course, with a 10-minute charging time. That combination of that range is so great, Ben. I couldn't drive 745 miles in a day.
Right. Well, and I know that we're not really close to it, but imagine that in 5 or 7 years, or whenever these finally come out, where automatic driving cars are. You could have cars that are self-driving, like taxis in populated cities, and they'd be able to go out for the whole day without having to go back and recharge. Stuff like that. Very exciting.
Yeah, and again, if you could come back in 10 minutes, be back on the road. Wow.
You would just need less cars. You would need less cars, and that's great.
Yeah, good point. And then to close out here, it says eventually Toyota's plans include vehicles with a 932-mile range. I think that's great, but most normal people, except for specialty applications, as you just suggested, that range is just beyond belief. And a less than 10-minute charging time. And in comparison, the best-selling EV today, the Tesla Model Y, has a maximum 330-mile range and a 15-minute charging time via Tesla Supercharger, which is all very, very impressive, especially that charging time.
If that technology were to come to market, and not even just like taxis or robo-taxis or anything like that, Ralph, imagine we ship goods via the highways all the time between states. Imagine having two people who could take shifts, never have to leave the cab unless they had to, and be able to ship something 1,000 miles away all in one charge. Like they could take shifts, they could sleep, they could do whatever they have to.
Yes.
Be able to like the cost of shipping goods would go down immensely as well. So
yeah, and related to that, just local municipal bus service and that sort of
buses
thing. Taxis,
too, yeah.
as you mentioned, whether they're autonomous or operator or a combination of human plus autonomous, whatever the case may be. The fact that these things, take the airport, at our airport, I'm sure yours too, and many around the world, you have the little shuttle things taking you out to the parking lot and all that sort of thing. This all could be all electric and a practical all electric because of range and charging time. So yeah, it's a great trend, folks. Hang on to your hats. It's coming.
And I also wanted to address a point because I never really bothered to go out and look for the information. So I have it. There's always the conversation of, shifting from a gas to an electric car, the electricity still has to come from somewhere. How much, how much more efficient is it really, versus gas that you put in your car versus versus electricity from the grid. And according to fueleconomy.gov, if you trust that, electric vehicles convert about 77% of the electricity from the grid to power out the wheels. So the actual energy it takes to turn the wheels, there's about 23% waste, and it's not a perfect system, but compare that to gasoline, where the energy stored in gasoline converted to, and you can imagine starting, stopping, poor driving can affect all this kind of thing. About 12 to 30% of the energy in gasoline is converted to power at the wheel. So you're getting, anywhere from 2 to 5 times as much efficiency for your for your electricity in just going electric versus gas cars. So very economical already. It's just a matter of solid state batteries are going to make it an absolute no-brainer.
Oh yeah. And again, I'm hopeful. Talking of the personal trend that I hope happens for me and my family is the day comes when I have to swap out my battery. Can I retrofit with a solid state?
Yeah.
I'm hoping that's the case. I haven't seen anybody address this yet, but that would be a question I would ask any of these engineers for any of these car companies.
At the very least, and I was just having this conversation with my wife about, getting a car in the future, and she's still a little on the fence about, even though 300 miles is a very far distance, there's still range anxiety out there.
Yes.
About going full electric versus hybrid, which I'm sure came up with your family too, Ralph, when you got when you got your Toyota. 900 miles, no one would have range anxiety at that point. That is, there is literally no benefit to gas versus versus electric cars. It's very little benefit if there is any.
Oh yeah. So. Yeah, that's a great point. And again, folks, if you're right now today, if you have range anxiety and you can't afford or can't access an all solid state battery car that we've been talking about, the ones right now on the road or in China, plug-in hybrid, friends. It's where you have a battery that takes our car. We've been getting anywhere from 40 to 50 miles of pure EV every day until it switches over to a hybrid mode, which is a combo, of course, of the other battery and the gas engine. So that's a great solution for right now, right this minute. And we'll see where we go.
Which most Americans drive less than 40 miles a day.
That's right.
It totally does the job. But either way, solid state batteries, there's so many applications. And like you said, it's already in pacemakers and medical technology and, a few other applications. Not just cars, but I'm sure if solid state is possible, you're going to see benefits across across industries. So there you go. Story number 1, great implications, and love it. Story number 2, let's go ahead and get a little bit more. I don't want to say realistic because 2028 is right around the corner, but this is something that's happening now. And honestly, it looks like a bath toy, but it's doing something so much more.
Yes, story number 2 is fun. Well, of course we must have artificial intelligence play a role in here, and we'll see it's got a couple of stories this week with that. Headline: This AI-powered robot fish explores mysterious organisms, and I added, and gathers DNA samples under the sea. And this comes from an absolutely joyful website called wonderfulengineering.com. And they kind of reposted a Reuters news story. So there's a double layer link, and there's a link, of course, in the show notes and the video you're showing the audience right now, which is really fun and cool too. So here's the story. There's an amazing new fish-like robot called Belle. that is exploring the ocean and gathering important information without causing any disturbance to marine life. This robot has the potential to revolutionize the way we study underwater creatures and environments and understand the impact of factors like overfishing and climate change. Now, Robert Katz-Schumann, assistant professor of robotics at ETH Zurich, of course, in Switzerland, he noted in reference to using the robot to explore sensitive coral reefs. See, that's hard for scientists to really get down there because coral reefs are so sensitive. Mm-hmm. He said those areas are particularly vulnerable to propeller-based systems that would just sort of shred through the corals or go and scare the fish away. That's the problem. So this is what this robot was really designed for, highly delicate and sensitive marine situations underwater. So Bell is designed, as the video wonderfully shows, to mimic a fish and seamlessly blend into its surroundings, thanks to its, here's the key, thanks to its silent movements. It uses artificial intelligence to navigate underwater autonomously. But that's not all. It can also collect DNA samples and capture high-resolution videos. Now, we're going to explain in a moment, how is it silent? Well, here's the deal. Bell is lightweight and compact, measuring less than a meter in length, weighing about 10 kilograms, that's about 22 pounds, when out of the water. Now, it uses a silicone fin with 2 water-filled cavities, which allows it to move quietly and naturally in coral environments deep beneath the surface. And a fellow named Leon Guggenheim, a mechanical engineering student at ETH Zurich, the Swiss Federal Institute of Technology, he noted these water-filled cavities are filled and emptied with water through a pump system that moves the fin back and forth. Because you have a cavity on one side, which creates an overpressure, and a cavity on the other side that creates a vacuum. And that bends the fin in one direction and conversely the other direction, right? To get the flapping motion of a fish. Isn't that something that's and the silence, the quiet, that's the thing that's so great. And Bell can operate autonomously for 2 hours before its batteries need to be recharged. Put a solid state battery in that thing, it could swim, it would have a 900-mile
range, yeah.
Yes, that's right. And when this is cool too, when the robot completes a session, remember it's autonomous, it's AI driven, it's going to do its thing. You deploy it, it goes and does its thing. When it's done, it swims to the surface, sends us a GPS signal, and then we go pick it up again, Guggenheim said. Now, news outlets have reported that this robot could soon become an invaluable tool for marine biologists. They could use Bell to study and protect the health and biodiversity of different reef ecosystems, ensuring the conservation of marine wildlife. And with Bell's help, scientists can gather crucial data while minimizing any disruption to underwater habitats. So I just thought this was clever. I thought the silent motion, the way they do it with the water-filled cavities, alternating and vacuum and filling and expelling the water and so forth. It's just, I thought it was and boy, there's the video you're showing right now. That looks like a fish. The movement is so fluid and so natural. It's just amazing to me. And it does look like those bath toys. My 4-year-old grandchildren have these little wind-up toys that look just like that. And they put them in the pool and they swim around for a few minutes. And yeah, it looks exactly like that.
Yeah, they certainly do. But in the video also shows a little glimpse on how they kind of extract the DNA from the thing. Because, it's swimming through the water. It has little cavities and it actually takes samples of the water that they can then pull out of little tanks that are on the drone. So very, very cool. And again, the fact that it looks like a fish, I do worry a little bit that, I don't know how common predation on drones is, but I'm wondering if they made it big enough, because 22 pounds, that's a big fish. I'm hoping that nothing's going to try to attack the drone. I'm not saying that it'll hurt the drone. I'm more worried that it might hurt the attacker, but still, it's very natural, very natural.
Yeah.
I'm imagining, Ralph, because we already have like buoys out there and stuff like that. If we could have some kind of like docking station thing where we just have like a research buoy out there, they go out, collect, monitor, come back, charge, and just do it all over again. so many possibilities, but still looking out for our little fishy friends is really important. So, being able to get constant real-time data is important. And this fish is, like you said, with the kind of pump system that they're using, looks just like a fish. Doesn't sound like a little propeller. It's perfect.
Nope.
These things were
I know,
really
isn't
cool.
that something? And then one other little nugget. Mm-hmm. Oh yeah, go ahead, Ben.
Well, no, I was just saying, and the AI navigation, like it's not just swimming in circles; it can actually navigate its surroundings. So even better.
Yeah. Isn't that something? And another thing, not to take it to the dark side, but this thing could be also for surveillance. This could be for underwater monitoring or surveillance security situations. This is for natural science research, which is lofty and good. But let's be honest, this could be repurposed for other needs.
Well, there are so many situations that we've heard of where boats will dump, waste. They'll dump cargo overboard. They'll just kind of throw nets and stuff like that. I mean, there's so many cases where you want eyes and ears on something, but something like this, you could monitor underwater, autonomously without having to, constantly, have a person out there. So there's good applications, bad applications, but still very, very cool research from Zurich. It's very innovative. So that's story number 2. Story number 3. And it's intriguing. It's clearly showing kind of the limitations of AI, but at the same time, it's showing the promise of AI, because it seems like 2 years ago, we were talking a bit about machine learning for years, but AI really broke onto the scene with, ChatGPT and, the other things that, kind of worked our way into our daily lives. Now, AI is just leaps and bounds every single, it seems like, month. We're talking about a new innovation that they're really working on. So story number 3 really goes to show that while still primitive, they're doing more and more complex things well. And that's scary, but cool.
It is scary, but cool. And this is a really good example of a glistening in the eye, early indication of a key trend that could just turn the whole semiconductor world upside down and inside out. And, possibly you could say in a positive way. But here's the headline. This comes from Quartz magazine. Very interesting. I just got onto these guys. Headline is, it only took 5 hours for an artificial intelligence model to design a functional CPU, central processing unit, or a brain chip, as the popular term is, right, for your computers and other devices and so on. So the implications of this are just astonishing. So a little background here. Artificial intelligence is stretching the human limits of computer design with a new AI model now creating a complete central processing unit, brain chip, in just under 5 hours, compared to the 4 years it takes Intel, for example, to build one. And this is a very generalized time frame they're using in this article, by the way, because longtime listeners know I worked for Intel for almost 14 years. And one of the things I did was I worked with the research part of the company, not as a scientist, but as a person who took it to the technical press. And I remember the first time they brought me in and said, we've got this processor that has something called hyperthreading and 2 cores. And I said, what? 2 processors in one, and the ability to divide and conquer? Now we're at 16 cores and the crazy stuff many, many years later. So I know from personal experience, not personally directly, but just from being associated with the research side of Intel up here in Hillsboro, Oregon, that it took, a great deal of time to develop and test and QA the design for a CPU. So with that said, here's the deal. This achievement, what we're talking about today, AI designing a central processing unit in less than 5 hours, was discussed in a research paper. Now, our show notes have a link for you there, dated June 27, so late last month, and authored by, here are the Chinese again, 19 Chinese computer processor researchers from 5 technology colleges in China. The researchers say their approach is bound to set the stage for the creation of self-evolving machines. What? Let that sink in. Self-evolving machines.
I just opened the research paper, Ralph. Unfortunately for everyone out there, it runs Linux. So
that's right. We're going to get into that.
No, that was a joke. But please go ahead.
No, yeah. In fact, a little preview here. There's going to be a lot of reality checks, which the researchers completely acknowledge that what they're talking about is a CPU would be 20 some odd years previous technology to where we are now. So nobody's trying to say that this is equal to your latest, greatest AMD or Intel brain chip, right? So no qualifier there. So their researchers say their approach is bound to set the stage for the creation of self-evolving machines, forever change the legacy CPU design flow, and reform the global semiconductor industry. Interesting. Now, the CPU these 19 researchers put together, which runs on an AI instruction set named RISC, and I presume, Ben, they mean 5, the Roman numeral 5, RISC-V 321A, can successfully run Linux operating system kernel 5.15. And that's part of the reality check you just alluded to. According to the researchers, it can perform comparably against a 1991 human-designed Intel 8486SX CPU. And again, I had a little comment. We've been saying that this is just the beginning. So we're not talking about designing CPUs comparable to today's speedsters. Well,
and it's also important to note that, Ralph, you know this very well, that when they design CPUs, it's up to really like the software engineers and the software designers to then take full advantage of that CPU. So you can't just take, a word processor or even an operating system and say, okay, well, it works on this CPU, so we'll just throw it onto this CPU and see how it works, and compare the differences. No, the developers hook it into the CPU and take advantage of the resources that they have. So you can't just say, compare one-to-one when the software was designed for that CPU, but obviously not for this new AI-generated CPU.
Right.
It's just not a good comparison to, do power that way. But you can see where, they're trying to do that.
Yeah. And again, in the theme of their honesty and their recognition that what we've done is we've created an AI-based processor generated that would be from 1991 class, okay? And so what they do say, though, in their papers, the ultimate goal is to beat the latest human-designed CPU. They really want to try to see if they can develop this enough to the point where it could be comparable to the latest, greatest processors from AMD, Intel, and everybody else, while shaping the future of computer. And then they have a quote from the paper: "Our approach reduces the design cycle by about 1,000 times because the manual programming and verification process," I can tell you from my years at Intel, that verification process is non-trivial. So the manual programming and verification process of traditional CPU design, which consumes more than 60 to 80% of the design time and resources, is completely eliminated, they contend, with their new AI-based system. So pretty interesting. They also said they said that it takes humans about 4,560 hours or 190 days to complete the entire design of a traditional CPU, such as the Intel. And they said K486. That's a mistake. They mean the I486, right. The 8486, which was announced, by the way, in Spring Comdex on April the 10th, 1989. Yeah, isn't that something? And the new AI-generated CPU, the paper states, achieves an accuracy of 99.99% for validation tests. That's impressive. While the physical design of the chip uses scripts at 65 nanometers technology to generate the layout for fabrication. Now, more reality checks here. The RISC-V 321A chip comes with a frequency of 300 megahertz as compared to Intel's human-made, basically the latest stuff, of 3.6 gigahertz processor, making it slower, needless to say, at processing computer commands. So again, we're talking about something that's just the beginning. Let's see how far they can push this. And a side note, today's Core i9 13900K has a base frequency of 3.5 gigahertz and a boost frequency of up to 5.3 gigahertz. So when we're talking 300 megahertz, it's laughably less speed, but the implications are interesting. And to wrap it up here, the researchers admit this. They're very clear about this, saying CPUs made using AI models perform worse than recent processors such as the Intel Core i7 3930K, and they plan to boost the performance. Here's where they're going. They plan to boost the performance of what they call the world's first automatically designed CPU by deploying more elaborated augmented algorithms. So
Right.
It's, it's the beginning.
there are so many caveats that I'm surprised that they even released this paper. But like one thing is it took 5 hours. Ralph, I guarantee you they are. You've prompted AI before. You kind of start with a prompt, and you say, you do this. You can refine it. You can say, give me a story that does this with this, and then like as it goes on, you add, and I guarantee, like, from giving the prompt, giving it 5 hours, and spitting out a result is very different than spending probably over a year developing that prompt and developing its input so that it can give you a reasonably good output. So even though it took them 5 hours, it really probably took them, hundreds or thousands of hours to even get to this point, not just that 5. But
I see what you mean. Yeah, good point.
To develop that input accurately, to really refine it. Right. So that's one thing I'm kind of looking forward to, Ralph, if they kind of get this working. Clearly, they're gonna. I'm sure by this point, the schematics for old CPUs are probably out there, and it probably has access to that information. I'm curious, Ralph, if they can use this, if they get it working well enough, if we can feed it what Intel is doing right now, or what AMD is doing right now, or whoever, and say, hey, is there a way that we can improve this? And that's where it gets kind of exciting in the short term, because we can, maybe the AI will be able to say, oh, well, let's try this, and we might get another breakthrough. That is pretty exciting, rather than just a new CPU from the ground up that an AI generated. Who knows? But still, very impressive, and kudos to them. Like so much research that you bring on the show, Ralph, which is perfectly good. This is step 1 of step 50, but it's an important step 1. So
right in target with the trends. Part of my correspondent job.
Absolutely. So that's story number 3. Story number 4. Let's go ahead and talk about this. Story number 4, you traditionally save for medical technology, and this week is no different. And Medical Express, what do they have?
Yeah, this is great. Again, the source for this story is medicalexpress.com. Great website. And in this case, the story is based on a publication from the National Institute of Biomedical Imaging and Bioengineering. So a very, very prestigious group here. The headline is Delivering Oxygen to Tumors. Really, it's more specific. Delivering oxygen to cancer tumors may be a key in overcoming radiation therapy resistance. Radiation therapy resistance. Now, cancer tumors, cancer cells, have a radiation therapy resistance issue that these folks are hoping to overcome. That's the essential thing of what's going on. So let's get into the story. For most of our tissues and cells in our body, of course, a lack of oxygen, hypoxia, that's HYPOXIA, is bad news. Well, yeah, it's like if I didn't use my CPAP machine at night, they tested me and said, Ralph, you were not breathing for well over a minute or more, and your brain's going to get fried. And I said, yeah, my wife can tell you that. So hypoxia, lack of oxygen for tissues and cells is obviously not a good thing. Cancer cells, this I thought was fascinating. Cancer cells, on the other hand, can thrive in these hypoxic conditions, which render tumors less susceptible to anti-cancer treatments, including radiation. That corollary there is really, I don't profess to fully understand the linkage there, but it's interesting.
Yeah, I mean, what immediately jumps to mind is if there's no oxygen, going there, there's just less, not transition. There's less like transaction between other cells. There's less oxygen, less blood flow, less movement of fluids and things like that. So when you get your radiation treatment, you don't have that exchange that's happening as much as other cells, so it's more resistant, Ralph. You're just not doing as many, you're not moving as much, medication, oxygen, blood, anything. Exactly. So that's harder to get there. Right.
Yeah. So again, this new research may offer a way to break through cancer's hypoxia-induced defenses. Just fascinating, I thought. So a team of researchers at Thomas Jefferson University and Drexel University, this team has devised a strategy, that combines ultrasound with microbubbles to deliver oxygen and cancer drugs to tumors. So it's this super combo of oxygen and cancer drugs to bombard the cancerous tumors. The results of their study, published in an outlet called Pharmaceutics, indicate that the method tested in mice, good old mice and rats, thank you again, and pigs, caused tumors to become more cause tumors to become more vulnerable to radiation therapy, resulting in slowed tumor growth and increased survival of the patient. The researcher suggests that with further development, their approach could be used to enhance the effectiveness of radiation therapy in the clinic for a variety of cancers. And then it goes on to say here, hold on a second, according to John Eisenbray, PhD and associate professor of radiology at Thomas Jefferson University, quote, "At the moment, there's very little we can do on the clinical side to overcome hypoxia," again, that's the lack of oxygen, "for radiation therapy. Despite it being well known and a documented limitation, the hope is that a more localized, more aggressive targeting of hypoxia, like we've done here, will overcome some of that." And then finally, Margaret Wheatley, a PhD, a professor of biomedical engineering at Drexel University, added, quote, "Whenever I say we're delivering oxygen to tumors, a lot of people say, well, that's crazy. You're going to encourage them to grow. That's a natural layperson for me, too. I would thought that initially as well.
Giving them more resources. How is that good? Yeah.
Yeah, how is that good? Well, it turns out it's something the cancer doesn't like. But radiation therapy, which prevents cancer cells from replicating, requires an ample supply of oxygen close by to be effective, she explained. And again, friends, I don't profess to fully understand this. I just love it, though, because it's another example of how the war against cancer is being fought 24 hours a day, 7 days a week around the globe. And we are going to get there someday. I swear we will. That will leave me with an optimistic note, even if I don't fully understand it.
No, we absolutely will. And, it really is just these little breakthroughs in the treatment, more effective therapies, just 10% here, 5% there, better odds of living another year, little by little, eventually, someone with cancer, it's not a death sentence anymore. It's just something that you have to get treated. So, this is another one, and definitely, ultrasonic micro oxygen bubbles. I didn't see it coming, Ralph, but I never really do with our segments here. So, ladies and gentlemen, if you want to find out more, Computer America, we have a whole section dedicated to Ralph and his segments. And everyone, until next time, every Friday, we'll catch you then. Bye, everyone. Have a good one.